The common conviction among most researchers is the theory of how things came to be, the main clarification for the starting points of the universe. It incorporates the making of stars, planets, and all life, including ourselves. Notwithstanding its fairly eccentric name, the huge explosion offers an unmistakable look into the universe's start. At first, the universe was consolidated into brief space, more modest than a pinhead, with particles thickly stuffed. From this minute point, a monster blast of issue followed, known as the enormous detonation. This occasion, happening billions of years prior, set up for the unfurling of infinite history. Notwithstanding, headways in logical information have prompted inconsistencies with forecasts of the theory of how things came to be. At the point when NASA sent off the James Webb Space Telescope, JWST, the biggest and most developed space observatory, researchers anticipated that its perceptions should support the theory of prehistoric cosmic detonation. Scientists were astonished by the telescope's unprecedented capacity to peer deeply into the past of the universe just 1 year after it was launched. The JWST's momentous capacities revealed systems from a period so old that it challenges how we might interpret the universe's starting points. This disclosure has started an intense investigation of what existed before the huge explosion. A critical revelation happened when cosmologist Rohan Natu, working with JWST information, coincidentally found a universe going back in only a short time after the huge explosion, making it the most seasoned world at any point noticed. The scientific community was shocked by Natu's discovery, which demonstrated the JWST's transformative potential. Its central goal to change our understanding of the universe has quite recently started, promising to reveal exceptional experiences into the earliest ages of the universe's presence. This barely investigated age holds the way to figuring out the development of the primary stars and systems. The telescope's discoveries have made heads spin, uncovering universes with qualities that outperform past expectations. Researchers have been forced to reconcile these observations with existing theories as a result of the intense scientific inquiry sparked by the unexpected abundance of early galaxies. Researchers are currently wrestling with significant inquiries regarding the key idea of the universe and the powers forming its advancement. With a sunshade the size of a tennis court, the revolutionary technology of the JWST, which is 1.5 million kilometers away from Earth, is shielded from terrestrial interference and kept near absolute zero. Its goal is to learn more about cosmic dawn, the time when the first stars and galaxies formed, using a huge segmented mirror and highly sensitive instruments. The telescope's perceptions have offered cosmologists a remarkable chance to test how they might interpret hidden peculiarities like dim matter, dull energy, and the collaborations among starlight, gas, and residue. By examining these old worlds, researchers can either affirm the legitimacy of flow models or reveal holes that could prompt new revelations. Albeit the underlying assumption was to find a couple of weak worlds, JWST's most memorable pictures uncovered various universes that far surpassed expectations in size, age, and iridescence. This surprising abundance of early systems has ignited a race among stargazers to establish new standards for the earliest known universes, provoking a reconsideration of enormous history. As scholars and onlookers scramble to make sense of these experienced worlds, some guess blemishes in the examination of JWST's underlying perceptions. However, these findings continue to be viewed as a paradigm shift in our knowledge of the early universe. These disclosures challenge standard cosmological models and proposition enticing signs about the idea of vast development. Our understanding of how the orderly universe emerged from primordial chaos may be rewritten if some scientists propose that the universe is even more peculiar and intricate than previously thought. The starting points of JWST can be followed back to 1985 at the Space Telescope Science Establishment, even before the Hubble Space Telescope was sent off. In contrast to Hubble, which primarily observes visible light, JWST was designed to observe the infrared spectrum. This enables it to examine early galaxies whose light has shifted to infrared wavelengths as a result of the expansion of the universe. This capacity is significant for opening the secrets of enormous first light. The need for a telescope like JWST to delve deeper into the history of the universe was reinforced by the 1995 Hubble Deep Field observation, which revealed a richness in the early universe. After more than 20 years of improvement and a $10 billion expense, JWST was at last sent off in December 2021, starting its most memorable year of science perceptions in July 2022. Early projects intended to look for early worlds surpassed assumptions, uncovering revelations that oppose customary models. Astronomers have been awestruck by the discovery of extremely distant galaxies through the initial JWST observations. 2015 saw the discovery of the most distant galaxy ever made before JWST. However, JWST's fast revelations, like system glass Z13, recognized 70 million years sooner in enormous history, exhibit the telescope's unmatched power. These discoveries challenge forecasts in light of the standard cosmological model, recommending that systems of such size and brilliance shouldn't have shaped so early. This test to the model has started discussions and re-examination among researchers. Some propose elective clarifications like altered Newtonian elements, while others center around the job of dull matter and energy. JWST keeps on changing cosmology, pushing researchers to rework the initial sections of astronomical history and provoking continuous disclosures about the universe's intricacy. As the competition to investigate JWST information proceeds, these historic discoveries feature the telescope's groundbreaking effect on how we might interpret the universe and set up for future investigations into the earliest ages of the universe. This limit is huge for opening the insider facts of tremendous first light. The requirement for a telescope like JWST to dig further into the historical backdrop of the universe was built up by the 1995 Hubble Profound Field Perception, which uncovered an extravagance in the early universe. After over 20 years of progress and a $10 billion cost, JWST was finally shipped off in December 2021, beginning its most essential year of science discernments in July 2022. Early tasks expected to search for early universes outperformed presumptions, uncovering disclosures that go against standard models. Cosmologists have been awestruck by the disclosure of very far-off systems through the underlying JWST perceptions. 2015 saw the disclosure of the most far-off world made before JWST. However, the telescope's unparalleled power is demonstrated by the rapid discoveries made by JWST, such as the system glass Z13, which was discovered 70 million years earlier in vast history. These revelations challenge estimates considering the standard cosmological model, suggesting that frameworks of such size and splendor shouldn't have molded so early. Researchers have begun discussions and re-examinations as a result of this model test. Some propose elective explanations as adjusted Newtonian components, while others revolve around the gig of dull matter and energy. JWST continues to change cosmology, pushing scientists to modify the underlying areas of galactic history and inciting consistent exposures about the universe's multifaceted design. These historic discoveries set up for future investigations into the earliest ages of the universe and feature the telescope's extraordinary effect on how we might interpret the universe as the competition to examine JWST information proceeds.